Lesson 7, Part 1, Graphing Systems of Equations. So systems of equations, whenever you see system, that means you're dealing with more than one equation at a time. So this is one system of equations. This is another system of equations. The first method you're going to use to solve these is just to graph them. Just put them on the same graph together, all right? So you make your x and your y-axis, okay? I'll make the first one a different color, so I'm going to make this one pink, starting at positive 2. 1, 2. My slope, now there's no number in front of x, so I'm going to assume that's a 1. Actually, you should always assume it's a 1 if there's no number there. So your slope is 1 over 1. So up 1 over 1, up 1 over 1. My line goes like this and like this. Another thing you can do, if it goes up and over, you can go backwards, down and to the left, because the pattern should be sticking the same. It should be the same pattern, okay? All right, the next one. I'll make it a different color. Negative 1. And the slope is negative 2 over 1. So it's going to go down 2 over 1. Down 2 over 1. And again, you can go up 2, just to kind of keep it in order. Okay. Now, it's helpful if you have graph paper because you're trying to find out where do these lines cross. Where does this happen? Because that's your answer. Your answer is wherever these lines intersect. You're looking for the intersection of both lines. That is going to be your answer. That is your solution. And the way you write that is as a coordinate. So this coordinate would be at negative 1, positive 1. So there's two numbers you're asking about. You're asking about the number for x and the number for y. So your answer should be as a coordinate, x and y, like that. Okay? And that's it. Now, sometimes it's going to be hard to tell, especially if you're doing it by hand. So just tell me how as close as you think it is. So if I thought that was negative 1/2, I would put negative 1/2 as my x, all right? So you're trying to figure out as best you can. So this method is used for estimating the solution, especially if you're drawing it by hand. Okay? All right, here. Now the top one is pretty straightforward. Negative 4. 1, 2, 3, 4. And the slope is up 2 over 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. So my line goes like that. That's the first one. Okay, the second one is a problem. The reason this is a problem is because this is not graphable. It's going to take a little bit of time to graph this. So your best option is to take this and we're going to change it. We're going to change the equation. Okay? So x plus 2y equals 6 has to change into y equals mx plus b. So you start by getting rid of the x, moving it to the other side. Cancels out, you can be left with this. Because I want it to look like mx plus b, except that 2 needs to also go away. So I have to divide both sides by 2. So you get y equals negative 1 over 2. Yes, remember there's a 1 there. X plus 3. And this is what we're going to graph. We're going to graph this on the line. So positive 3. Slope is down 1 over 2. Down 1 over 2. Down 1 over 2. Down 1 over 2. Draw my line. You see, again, it's hard to do it by hand, but I'm going to say this is where it crosses. So this would be the point 1, 2, 3, 4, 5, 6, 0. And that's my answer. And that's what you're doing with systems of equations. You're graphing them. Now, sometimes you'll get a couple different answers, okay? Now, if you see this, the top one you can graph. The top one's not a problem, okay? It's going to start at negative 1, up 3, 1, 2, 3, over 4, 1, 2, 3, 4. And there you go. And again, if you go backwards, you can go down 3 and left 4. over there. Just going in the same pattern. Now, this one is the issue. Again, you cannot graph this one the way it is. So we have to move things. In this case, I'm going to move the 3x to the other side of the equal sign. I like to put this first because I like it to look like mx plus b, because that's how you graph it. That's not a b. It should be negative 8. Sorry. Apologies. Negative 8. Okay. Divided by 4. Oh, and it's a negative 4. I forgot that. There's a negative sign here, so you're dividing by a negative 4 entirely. Be careful with that. If you're dividing by a negative number, everything's being divided by that negative number. So this becomes a positive 3 over 4. This becomes a positive 2. Don't change it to a decimal right now because you're going to graph it. Okay, so this starts at positive 2 up 3 over 4. Okay, these lines should look familiar to you. They're from a lesson from last week. These lines are parallel, which means they do not intersect. They will never intersect. So guys, this is a no solution. If the lines do not cross, there's no solution. Now, it is possible sometimes that you can draw the line on top of the other one. If you draw both lines in the same place, that is infinite solutions. That basically means both equations are identical. So if this number was a negative 1, it would match the first equation. They would be in the exact same place. That would be infinite solutions because they're intersecting everywhere. They're crossing everywhere. But these aren't crossing at all. That's a no solution.